Okay, in this video we're going to look at elementary operations that one can perform with matrices. Okay, and it's quite exciting, and it's very, very important that you know what to do when you add, subtract, or multiply matrices. So the first thing we're going to look at is what do we do if we add two matrices A and B? Well, first of all, before you can add two matrices together, there's an important fact that we need to wrap our heads around. We cannot have matrices where the dimensions are not the same. Okay, that's very important. You can't add those type of matrices. So if we look at the matrices here, we see that the following is indeed true. This is an m by n matrix, and that is an m by n matrix. So we can add them together. Now let's see, how do we do that? Well, first of all, how does this come to be? A11 plus B11. Well, it takes entry A11 and it adds it to entry B11 to get to A11 plus B11. If we look at the next entry, A22 plus B22, in the sum of the two matrices, it's the two corresponding entries in the two different matrices that are added together. So you add the corresponding entries in each of these matrices when you add two matrices together. And very important, both matrices have to have the same dimensions. So they've got to be both 3 by 3 or 4 by 4 or whatever the case is. Notice that they don't have to be square matrices here, but they have to have the same dimensions. Okay, so if we look at this, let's see. I add one, or first of all, before we start adding, this is a 3 by 2, that's a 3 by 2 column. Okay, so the result will be 3 by 2. Why? Because we're going to add corresponding entries. So we add the 3 and the 0 to give us 3 plus 0 and leaves us with the 3. The 1 plus 0 is a 1. Just look at this entry here. 0 plus 5 is 0 plus 5. It then gives us a result of 5. Okay, so those two are added to lead to that, and 3 and 0 will be added to lead to that entry. Now let's see, is the same true? Here we were adding. What happens if we subtract? Well, the intuitive thing is that you subtract corresponding entries. Let's see if it's the case. 1 minus 0 gives us that, gives us 1. Let's go for 2 minus 1 is over there and is 1. So indeed, the same when you subtract. You subtract corresponding entries, but to be corresponding, the dimensions of each of these matrices have to be the same when you add or subtract them. Okay, so the question, can you add two matrices that do not have the same dimension? And the answer is no. They have to have the same dimension. How do we add or subtract? We use corresponding entries in the two matrices. Okay, so let's see. This is very important, folks. Multiplying two matrices together. In order for us to multiply A and B, we've got to make sure that the number of columns, this is interesting, the number of columns in matrix A is the same as the number of rows in the second matrix B. That is the most important prerequisite for you to be able to multiply matrices together. So for the first matrix, the second entry in the dimensions must be the same as the first entry in the second matrix. So let's have a look. There's an M. That doesn't matter yet, but it's an m by n matrix. Okay, so this has got to be an n by whatever. As long as those two there are the same, then the matrices can be multiplied with one another. So this will be an m by k matrix after you've multiplied the two together. So this tells you whether the product is defined. Okay, so let's have a look here. There's 1, 2, 3, 4 rows and there's 2 columns. So the second entry is 2. There's 2 rows, first entry, 3 columns. Okay, so this will be a 4 by 3 matrix. The columns in the first matrix is equal to the rows in the second, so we can proceed and multiply those 2 matrices together. Okay, so multiplying the elements of each row in matrix A by the elements of each column in matrix B. Very important. Let's see how it works. The elements of each row in the first matrix. So this row, the number of rows here determine the number of rows in the final product. The number of columns in the second one determines the number of columns. So if I look carefully, I can see here that there's 3 columns, column 1, column 2, column 3 that corresponds to the columns in the second quadrant, and 1, 2, 3, 4 rows. 1, 2, 3, 4 rows that corresponds to the number of rows in the first one. Now let's see, how am I supposed to multiply these together? Oh, I want my pen, sorry. So if I look at the first row over here, it says multiply the elements in each row by the elements in each column of the next matrix. So if I use row 1, I must use column 1. How do I multiply? Well, I take 7, I multiply it by 7, there we go, plus then the 3 multiplied by the 8, 3 times 8. If I add the 2 together, I have entry number 1 in the resultant matrix. Okay, so very important that you see that. Let's look at another one. Let's look at the second entry in that very same row. This is very important, folks. You've got to understand this. So if I take 7 and I multiply it now with the 4 over here, I'm creating this entry there. So 7 times 4 plus 3 times 1. And that gives me the second entry in my second matrix. For the third entry, this entry over here, I take this row and I take that column. So 7 times 9, there we go, plus 3 times 5, there it is. Okay, so for the first entry, I take first row, first column. For the second entry, first row, column 2, because it is in row 1, it's column 2. For the third entry, it's still row 1, but column 3 for that top entry. So row 1, column 3, row 1, column 3, row 1, column 2, row 1, column 1. So if I now want to look at my second row, let's get rid of that. If I want to start multiplying my second row, I need to use row number 2. So for row number 2, entry number 1, row 2, column 1 is that combination. So I take 2, I multiply it with 7, there it is, plus 5, that's multiplied with 8, there it is. For the second entry here, it is row 2, entry, column 2. So row 2, column 2 in my matrix here is 2 times 4, there we go, plus 5 times 1, there we go. The third one I will use 9, 5. So I will go for row 2, column entry 3. So 2 times 9, there it is, plus 5 times 5, there it is. Okay, now folks, you carry on in that fashion to go for the last row here, the final row. Oop, that looks a bit cockeyed, but let's see. That's my final row. 9, row 4, column 1, the entry. So you use the fourth row and you multiply it with the first column. So 9 times 7, there it is, plus 0 times 8, there it is. The next entry is using row 4, column 2. So this is entry in row 4, column 2. So 9 times 4, there it is, plus 0 times 1. And you continue in that fashion, folks, and you get to your final product. Once you calculate all of these at the top, if you calculate all of these that you did over here, you add, multiply, and you add each sum, that's what it totals up to. So let's just remind you about the very important precondition. This is a 4 by 2, 4 rows, 2 columns. This is 2 rows, 3 columns. So the resultant, so these two in the middle are the same. The resultant will be the 4 by 3 matrix that we have on the screen. Okay, so let's see. In order to multiply two matrices together, what's important? The number of columns in the first matrix must equal the number of rows in the second. Then you can proceed with that product. Now, if we look here, there's 2 columns, there's 1, 2, 3 rows. So 2 columns, 3 rows, no, icona, we can't use that. We can't multiply them together because their dimensions are their columns in the first is not the same as the rows in the second. So the number of columns is not equal to the rows. Let's have a look here. There's 1, 2, 3, 4 columns, 1, 2, 3, 4 rows. So definitely we can continue. Now let's just check. Entry number 1 in this matrix is row 1 multiplied with column 1. So it's 1 times 1 plus 4 times 2 plus 6 times 9 rather, plus 10 times 3. And that will bring you to your first entry. Okay, so it is a legal product. The resultant is going to be a 2 by 3 matrix. And there are the products as we were hoping to find with that problem. So let's have a look at some more multiplication. We're going to look at multiplying a matrix by scalar. Now a scalar is any number C. We're just going to represent it with a number C. The matrix has a name A, therefore the entries are A1, A2, A3 for now. Okay, so if I work out the product, it means I just multiply every one of those entries with a C to get to the matrix C times A. So quite straightforward, nothing complicated about it. Okay, so let's look at a few examples. Just remind yourself, if I multiply two square matrices of dimensions 2 by 2 with each other, it's that entry times that entry plus this entry times that one. That is entry number 1. For entry number 2, I'll take those two and multiply, and we continue in that way. So I'm going to leave it on the screen, and we're going to look at this product. Now I'm going to ask you to pause your video at this point and to work out the product of that square matrix, and then come back and see whether you were correct. Let's have a look. You took for the first entry here in the multiplication, these were square by square matrices, so they will always have a product. So 2 times that plus 4 times 2. So 2 times 3 plus 4 times 2. Perfect. And then 2 times 3 plus 4 times 7 for the next one. And the same here. 1 times 3 plus 2 times 6 for the bottom entry. And for this entry, we have 1 times 3 plus 6 times 7. If we add that together, there's the result of that product. Okay, now let's see what happens if we multiply 3 by 3 together. Well, exactly the same thing. For the first entry, we multiply row 1 with column 1. So it will be A11 plus B1 times B11 plus A12 times B21 plus A13 times B31. Now look at that. If you multiply A12 with B21, the 2 and the 2, you have a 1 by 1 matrix, which is just that simple entry in the answer. So the method is the same. you multiply in that same fashion. You can think of it like starting here and multiplying across. So you're doing that in your product. Okay, for a 3 by 3. Let's put you to work and let's see what do you get if you multiply those two together. Now again, pause the video, do the problem, and then come back and see if you are indeed correct. Okay, let's see what you did. You took the first row for entry number 1. This entry over here is the first row multiplied by the same, so the first column, 2 times 3. There we go. Plus minus 9 times minus 3. So plus minus 9 times minus 3, plus 3 times 3 for the third one, and there's your entry correct. So we do that for every single one of those entries, and the result that you were supposed to get is the matrix at the bottom. Now if you didn't get that matrix, just pause the video, go back, do it again, and see where you made a silly error. It's really just a silly error. But you've got to be fluent in multiplying matrices, because we are going to use that quite often. So I'm giving you another chance. Let's look at that matrix, 3 by 3 multiplied by 3 by 3, 2 square matrices. Pause the video, multiply, come back and look at your answer. Okay, so that is your result, and hopefully you got to that exact answer. Remember again, the first row multiplies with the first column to give the first entry. This fourth row multiplied with the fourth column there gives us, or rather third row, third column gives us the entry over there. Just a reminder. So try this one, pause the video, try it, come back. Okay, there's the result. And I'm sure most of you got that result now. But you have to get into that rhythm of training your eye across this row, across this column. So there's another one. Pause the video, try it, and come back. Okay, there's the result. And I'm sure you're becoming far more fluent at these products. Now I'm going to make it a tad bit more difficult, and I'm going to throw fractions and a few negative numbers in there. So pause the video, multiply, and then play to see if you were correct. Okay, if you multiplied correctly, that would be your answer. If you didn't, don't worry, there's another one for you. So pause, try it out, and come back. Okay, and I'm sure this time around you would definitely get the result. You can see it's pretty ugly because there's fractions in here, and we know that people stumble over fractions. So please practice 2 more. There's 1 more for you. Pause the video and then see if you're correct. There we go. Okay, lovely. Those fractions look, denominators 15, 3 and 2. It's all over the show. Last one for you to practice with is on the screen, so pause and come back. Okay, there's your result. It looks even worse than the previous one that we just had. Okay, so folks, you have to be fluent at multiplying 2 matrices together. So if I look at the notation on the screen here, I've got a matrix multiplied, so a square matrix 2 by 2 multiplied by a column matrix xy, and that gives me the result ax plus by. Now you can see this more or less looks like the functions that you work with at school. Okay, so I'm introducing this notation. Later on it's going to become important when we do work with algebraic equations. So how do I get the first entry? Well, let's first see 2 by 2 there. 2 by 1 is a 2 by 1. 2 rows, 1 column. So it's that multiplied by x plus b multiplied by y gives me the first entry. Then c multiplied by x plus d multiplied by y gives me the second entry in that matrix. Okay, so that's 2 by 2, 2 by 1. The result is a 2 by 1 matrix. So another column matrix to think about. Okay, and the same works with the one at the bottom. We have a 3 by 3 matrix multiplied by a 3 by 1 column matrix. So the result is going to be 3 by 1. Remember, this tells us that the product is indeed possible. That tells us the dimensions of the product itself. Okay, so that's how it works for a square matrix multiplied by a column matrix. There's one. You'll see the previous one had zeros here and a 1. This is in general, every entry is different, x, y, z. Now imagine if those were 3 equations that you were trying to solve in the variable x, y, and z. How long it will take you. Solving these two simultaneously is going to be easy. But working with a system like that takes a little bit more time, and you need to understand how to work with it. There's your dimensions, just to remind you. There's a 4 by 4 square matrix multiplied by a 4 times 1 gives us a 4 by 1 result. Okay, and that's 4 by 4 and 4 by 1. I wrote there 3 by 1, and here's 3 by 1. So that was a bit silly. Those 3's are supposed to be 4's. Okay, so let's look at this last example where you multiply now a row matrix with a matrix that looks like this, a square 3 by 3. So this is 1 by 3. That is 3 by 3. So let's multiply that. Pause the video and then we'll see if you did that correctly. Okay, let's have a look. A 1 by 3, does it exist? Multiplied by 3 by 3 gives a 1 by 3. So 1 row, 3 entries. And those entries are 2, 3, and 1. Okay, so you're going to continue. The result will only have 1 row, but 3 columns. 1 row, 3 columns. 1 row, 3 columns. 3 different ways to see that. Let's try another one. Multiply those two together and let's see what you get. Pause the video and then come back. Okay, so you were supposed to get the row answer, the row matrix 3, 3, 1. 1 row, 3 columns. Okay, so let's continue multiplying with the identity or the unit matrix. Multiplying by the identity matrix I, that is an I, does not change anything very important. Just like multiplying with a number 1 doesn't change anything. Okay, so the property is y1, y and 1 are each, yi and 1 are each other's multiplicative identities. Okay, it's a lot of words just to show that if you multiply the two of them together, you are going to get the same matrix at the end of the day. Let's see if this is true. 2 times 1, okay, minus 1 times 0 minus 3 times 0. So that doesn't change. So this result is going to be 2. Let's check this if I multiply the second row. So I'm multiplying row 2 with the identity matrix. So 3 times 1, 4 times 0 minus 2 times 0. So it leaves me with a 3 where there was a 3. Let's go for the second. 4 times 1, oh sorry, here. I'm going to multiply this with my third column over here. So I'm creating the entry here at the end, that entry there. So 3 times 0 plus 4 times 0 plus minus 2 times 1 gets me exactly that. So indeed, if you look at this, if you multiply any matrix with its identity matrix, the matrix remains unchanged. Okay, very, very important to know that. If I multiply that, I can expect to have, after multiplication, the same result. If I multiply those two together, I end up with the same result. at the end of the day. Now you can check it, folks, by looking at the interim part here and then seeing for yourself that definitely you're going to get 2, minus 1 and 3. Remember, this determines the rows in the resultant column, which is 1. There's 1 row, and then there's 3 columns. So there's 1, 2, 3 columns in the result. Same for that one. It remains 3 minus 12, 6 and 4. Now you might ask, but why? Why do we multiply with the identity matrix if it just gives us the same matrix? The only thing that this does is show you that if you multiply any matrix with its equivalent identity matrix, the matrix remains unchanged. Now that's going to become important in work in the future, so please remember that property. So let's finish this presentation by looking at important facts. The properties of scalar matrix multiplication: if you multiply with a scalar that's the same as, so it's like algebra, A times B multiplied by C is the same as A times B multiplied by C. Alpha beta is the scalar product multiplied by the matrix A is the same as beta alpha multiplied by the matrix A. Well, 2 times 3, 3 times 2, same thing, so it's almost common sense there. The properties of matrix to matrix addition, commutativity and associativity holds for matrix addition. So if you have A plus B, it's the same result you're going to have if you add matrix B to matrix A. If you have matrix A added to the sum of 2 matrices B and C, then the sum of matrix A plus B plus the third matrix is the same as if you would have added the last 2 together and then add to A. So the commutativity and associativity laws apply to matrices as well. Matrix to matrix multiplication, A times B times C, is equal to A times B times C. But the reverse is not true. So if I have A times B, it's not the same as B times A. Now folks, let's think about why. Why is this the case? If you remember what we said earlier, if you have a M by N, then you must have a N by P to multiply with, and the result will be that. But if you turn them around, you're going to have an N by P that you are multiplying with an M by N. And those two are not the same. So that product can't happen. This product could happen because these two were the same. Okay, so remember that. The number of columns in the first matrix must equal the number of rows in the second matrix. Okay, for that product to be allowed. And then, important facts about the identity matrix is the identity matrix is always a square matrix. So it consists of the entries A, I, J, which we say is 1 if I is equal to J, and it is 0 otherwise. That's an algebraic way to think about the identity matrix. Okay, folks, I hope that helped you understand the elementary operations that we can perform with matrices. If you learned something from the video, please like it, share it, and subscribe to my channel.